Hello, students. Welcome to our lecture on wind energy in our clean energy series. The main learning objectives for our lecture is to understand the basics of wind energy, the science behind wind energy, the mechanics of it, a very brief history of it, the types of wind turbines, and what are the main advantages and disadvantages of wind energy and the future of energy. So when we say wind energy, we are harnessing the kinetic energy of wind to either for doing work like mechanical work or for producing electricity. It is sustainable, it is clean, and it's domestic. You don't have to import anything. It's very effective. And the future for wind energy looks very bright. It's one of the prime sources of renewable energy that we have to address climate change. It has very small carbon footprint. Wind is powered by the sun. The sun, by its effects, produces differential heating of the Earth's atmosphere and surface. And because of this, high pressure and low pressure areas develop, and that causes wind. So this causes vertical and horizontal air currents. And it's also affected by the contour of the land and also by the Earth's rotation. And this is what we need for creating wind energy. The energy from harnessing energy from wind has just like taken off the last century. So you can see here, just this last 17 years, there's this exponential growth of in USA. Kansas, Iowa, Oklahoma, and Texas being the prime producers, making 52% of the wind energy. And here in the global scenario, we can see that most of the wind energy and wind farms are found in China. They are ahead of the game. And there's this race going on to, transition to renewable energy. USA 18%, China 55%. And here's some interesting facts. So in USA, as of 2021, we've developed over 67,000 wind turbines, and it is contributing to about 8.4% of the electricity in USA. Department of Education has projected that we have about 404 gigawatts of wind energy capacity projected by 2050. Worldwide, the wind energy is contributing to 6% of the world's energy needs. And here's an interesting sentence. Every 24 hours, wind generates enough kinetic energy to produce roughly 35 times more electricity than humanity can use each day. Look at the tremendous potential here. So how much wind do we need? What is the average wind speed that is needed to harvest and make electricity? So here, this is the energy wind speed map of USA. And the orange region and the reds is the part of USA which has more wind. So you can see the wind energy is providing 10% of total electricity generation in 16 states, and most of it comes from Kansas, Iowa, North Dakota, and South Dakota. And here are the windmills. There's another graph, and you can see there's a high concentration of wind turbines and wind farms in this region here. So we need, so like it says like at least 10 kilometers per hour speed is required. And this is a very brief history of wind power. Since there are reports that show human beings have been harvesting wind energy from thousands of years ago. You know, the Egyptians had built ships that sailed with sails 5,000 years ago. And then like hundreds and thousands of years ago, they had the wind mills for either grinding the grain or for pumping water or cutting wood and so forth. But the first known electricity generating wind turbine was designed by a professor called James Blyth in Scotland in 1887. And the first large wind turbine was made by Charles Brush in Ohio in USA. So these are important milestones. And then very soon after they had the technology, it started to pop up all over, you know, and now wind turbines are a common sight when you drive down the different states of USA. What is the difference between a windmill, the old-fashioned windmill, and a wind turbine? So in windmill, the wind energy is converted to mechanical energy for pumping water or for grinding grain. Whereas in wind turbine, the wind energy, which is actually a kinetic kind of energy, is converted to electrical energy by using a generator. So this is the main difference between these two technologies. What are the different types of wind turbines? One is a horizontal axis. So this is the common one, is the horizontal axis wind turbine, HAWT for short. Here you can see the blades spin on an axis that is parallel to the ground. And the entire machine pivots or yawns, as they say, yaws, around the face of the wind. Whereas the vertical axis wind turbine, see this one, they say it looks like an egg beater. Here the blades spin on an axis that is perpendicular to the ground. However, the horizontal axis is more efficient. And there's like these common types of vertical axis, Savonius and Darius, that you might come across. The vertical axis is able to capture more kinetic energy, and hence it's more efficient. And this is the most popular one that you'll see standing on a tower. Let's define some terms. Yaw, as we saw, is the rotation on its axis, and furling is when the turbine is either pointing towards the wind. So it will, in order to capture more energy, it will point towards the wind, or it can tilt back. That's called furling. So this main feature is to protect the turbine from high winds and for stability. And also to, face the wind and get more energy when the wind speed is low. Here's an overview of how wind energy works. So we have a tall tower, and you can see the blades. So when the wind hits these blades, there is a junction here, and then it makes the blades to spin. So kinetic energy is transferred to mechanical energy. So through a whole series of gears, this can be amplified. And then that turns a shaft in a generator, and then it makes electricity, direct current, and then there's a converter that makes it into AC electricity, and then it can be transferred to the grid. Here's the same thing. So you can see the rotor blades, and the junction is called as the hub. The body where all the gears and generators and controller is kept is called as the nacelle. So the wind movement spins the turbine blades, which captures the kinetic energy and converts it into the rotary motion of a shaft here. That is that will drive the generator to make electricity. So let's look at this in more detail. So here's a very detailed picture of the different steps. So the different parts are the tower. The tower can be 80 to 100 meters, and that is becoming bigger and bigger. Towers are becoming taller and taller. As STEM innovation happens, people are building it better because it's able to harvest the wind at higher altitudes, which is high speed. And nacelle is the body. So there's the rotor and the blades, and there'll be a power converter, a generator, and a wind shaft inside. So the rotor consists of 3 blades and a hub. That is the rotor. And when the wind blows, see, over the blade, low pressure will be formed on one side of the blade. So this low pressure pocket will pull the blades toward it, causing the blade to turn round and round. It's almost like, the lift and drag that we've studied for airplane wings. The force of the lift is much stronger than the wind's force in the front side of the blade, and that is called as the drag. So the combination of the lift and the drag causes the blades to spin like a propeller. Again, propeller like in an airplane. The blades will capture the kinetic energy from the wind and convert it into a torque that is transmitted to a gearbox. So this is where there's a series of gears that is connected to a shaft. So when the shaft spins, it will create electricity. And the job of the gears that are found here will increase the rotation of the rotor. The most common is like 18 revolution per minute. Shaft speed can be increased and amplified to 1800 revolutions a minute. So a lot of amplification happens here in the nacelle by the gear system. There's also a controller that is connected to the anemometer. Anemometer is the wind instrument to measure the speed of wind. And when it gets dangerously high, the controller can put a brake on it and stop it and slow it down and so forth. It's for safety reasons. The yawing mechanism will allow the turbine to rotate on the vertical axis so that it can face the wind. This is what increases the efficiency of capturing the kinetic energy. So as I told you, as the shaft rotates, it'll in the generator, it will start to make electricity. And a transformer will increase the voltage from the generator to on-site collection system voltage. And then the controller will make sure it keeps the rotor speed from exceeding 55 miles per hour to prevent any damage to the machinery. So an anemometer is constantly measuring the wind speed. There's a brake so the brake will be applied when at extreme high wind speeds. And then when the electricity is made, it can be converted to AC current, and then it is added to the grid. What is a rotor swept area? So here, if you see the formula of the power generated by a windmill, it depends on the density of the air, the area. It's the squared effect of this change in the radius of the blades and the velocity of the air. So this is the formula for it. So here you can see at different the area that is occupied when the blades spin is called as the rotor swept area. So the area of the circle, which is delineated by the tips of the blade in the wind turbine. This is for a horizontal axis wind turbine. A typical 600 kilowatt wind turbine has a rotor diameter of 43 around here. So as this increases, the wind power will also increase as the diameter increases. The rotor area increases with the square of the rotor diameter. So a turbine twice as large will receive 4 times more energy. So coming to the number of blades, a wind turbine can either have 1 blade, 2 blade, or 3 blade, but it's the 3 blade one which is the most common and also the most efficient. Why is this the most efficient? Because it's this structure that is also the most stable. See, when 1 blade is facing the ground, 2 others will be on top. So it offers the most stability. So a rotor with an odd number of blade is like a disc when calculating the dynamic properties of the machine. So the angular momentum stays constant because when the blade is up, the other 2 will be down. And so that's why you see this is the most common, the 3 blade wind turbine. And wind turbines, they have tremendous potential. They make a lot of energy, and they have also grown in size over the years. So here is an example of a wind turbine. It's called Halley 8. So this was in 2018. It was one of the most powerful wind turbines. So just imagine, it's 220 meters. Almost the size of Eiffel Tower. So you can see the other, landmarks in the world. It's much larger than the Statue of Liberty. It's almost the same size as Eiffel Tower. So it's huge. And it's becoming more and more common now to build these huge, huge wind turbines, especially offshore ones. Siting. So a lot of thinking goes into the location of the wind turbine. It needs a very good site. Usually, like top of a hill is perfect because the wind speed is high and turbulence is low. So there are 2 things you look for. You're looking for an unobstructed wind flow, not close to any tall objects, and less turbulence. So siting is a very important factor when they're designing wind turbines. It has to be away from tall buildings, other turbines and trees, and topographic obstacle. They look for an area where the wind is not very turbulent. Usually the top of a hill is ideal, and also like a pass between mountains where the wind is gushing between the mountains. That's a good spot for it also. To be considered as a good location for wind energy, the area must have at least 12 miles per hour wind speed. There are different types of wind turbines depending on the size. The small one that is found in homes, and it's usually grid connected. So here's like a small farm, especially like in farms where it's off grid. This is very popular option. It's small, producing about 10 kilowatts, and the intermediate would be larger size. This is common in like cities, like I've seen it in football fields, just powering one like college or an institution, intermediate size. And the large, huge ones are the commercial ones that make a lot of electricity. And a whole bunch of wind turbines is called as a wind farm. The largest wind farm is found in China, Gunsu, and I think there's about 7,000 or more wind turbines in that area. It's very important to understand that wind technology nowadays is more concentrated on wind power from the ocean, because the wind over the ocean is the speed is very high. So here, this graph is showing the cumulative offshore capacity of wind, and you can see how it has tremendously increased over the years. So offshore, when they say offshore, it's the generation of electricity by wind turbines that is found above a body of water. It can be the ocean or a lake, because the wind speed is very, very high here. And of course, there's less turbulence, and there's no tall structures adjacent to it. And there's very less controversy. There's not much, complaints about noise pollution and so forth. So here you can see how the wind turbine can either be close to the shore. There's also floating wind turbines now, deep water floating wind turbines. It's mind-blowing to think that these huge structures can be placed in the ocean. And this world map here shows the potential of offshore wind energy. So everywhere you see red, it has very high potential. So after the electricity is made, they'll use undersea cables to transmit the electricity to the grid. So the main advantage of wind energy or wind power is that it's highly efficient, it is free, it is domestic, and of course it is clean energy. And again, that is reason enough. If we are going to mitigate climate change, and if we are transitioning to clean energy in the next 20 years, wind power is going to play a huge role in the world. There is no greenhouse gases produced. The land beneath the wind turbine can still be used for farming. Some people think, I think it's very beautiful, and it can be a good tourist attraction, it says. And for people who are living off the grid, wind power is very efficient. The main disadvantage is that it is not predictable, because wind is not predictable. So there will be days when there's high electricity produced, and some days when there's not. The areas for wind farms where it's very breezy near the coast, the land is expensive. Environment-wise, it can cause a lot of trouble to birds and also migratory birds. It can affect television reception. It can be noisy if it's in a neighborhood. So these are the disadvantages. And here's some futuristic next generation wind technologies. I thought it was very cool. This looks like this huge helium balloon that is floating. It's a wind turbine. And this bladeless wind turbines. And this is the offshore one that I was just mentioning. Here's the vision report from the Department of Education, US Department of Education. This shows the wind energy is a very viable source of renewable energy in all the 50 states, and we will be using a lot of it by 2050. Another important feature of clean energy, both solar and wind, is that it's creating a lot of jobs. More than 600,000 jobs in manufacturing, installation, maintenance, and supporting services in the wind turbine industry. And as it's becoming more and more popular, it's getting, the price is getting reduced, and efficiency is becoming higher with a lot of R&D that is going on. This land-based utility wind is one of the lowest priced energy sources available today, costing only a few cents per kilowatt after the tax credit. This is the last slide that shows how solar energy and wind energy can complement each other, because the peak electricity production can be at different times for both of them. So here you can see a home that is powered by both PV and wind. So for example, if you just take December, when the sun is not harsh, the solar energy is reduced, but the wind energy is increased. Whereas in the hot months, there is more solar energy and less wind energy. So together, they are a powerful combination to produce a steady output of electricity. And I hope that was helpful.